These are the frequently asked question videos for Algebra 2 for the mid-chapter quiz for Chapter 5. Starting with number 1, it says, for each polynomial function, describe the end behavior of its graph. So I'm looking for that highest degree, and I see this is a degree 8 polynomial. And that the leading coefficient is positive. So what that tells me is this is going to be parabolic in nature, and because it has a positive leading coefficient, the end behavior can be described by these two arrows. Again, the terms behind the x to the 8th probably going to make some wiggle room stuff down there. But what I know is that those end behaviors are going to be up and up. So we are going to write this using notation that would be correct for pre-calculus, which is the limit as x approaches infinity of our graph f of x is. Well, that would mean as you go to the right forever on this graph, where is it going? And it is going up, so that will be to infinity. And then the limit as x approaches negative infinity, which would indicate going to the left forever, our graph is also going up. So that would be positive infinity. Again, the notation stays the same. This is the only piece that we are really filling in for that notation. And so for this one, this is going to be because it's going up and up, infinity and infinity. And that is the end behavior description. Then for number 4, what's the degree of the function that generates the data shown? And what I do is I take a look at the x's, and I've got -3, -2, -1, 0, 1, 2, 3. And what I'm trying to check there is, does the interval stay going up by 1 all the way through? And it does. So then the next thing I do is I start finding the differences. So I'm going to take 159 minus 29 and get 130. Then I'm going to take 29 minus a -1, which will be plus. -1 minus a -3 is -1 plus 3, which is 2. -3 minus a -1 is -3 plus 1, which is -2. -1 minus 29 will be -30. And then we have 29 minus 159, which will be a -130. So this was my first set of differences here, and they do not match. Those are not a constant, so I keep going. 130 minus 30 is 100. 30 minus 2 is 28. 2 minus a -2 is 4. -2 minus a -30 is -2 plus 30, which is 28. And then -30 minus a -130 would be -30 plus 130, which will be 100. That was my second degree differences, and they also are not the same. So now I'm going after 100 minus 28, which would give me 72. 28 minus 4 is 24. 4 minus 28 would be a -24. And then 28 minus 100 would be a -72. That's my third degree difference. Still not seeing something common to both. So then I need 72 minus 24, and that is 48. 24 minus a -24 is 24 plus 24, which is 48. And -24 minus a -72 will be plus 72, which is 48. So there it is. It took the fourth difference in order to get this to be a constant. So that means this is a degree 4 polynomial that would generate this data exactly as it is. Then number 6 says find all the solutions of each equation by factoring. So number 26 is 27x cubed equals 8. And before we can factor, we have to move everything over to one side, because when we're solving, we're trying to find the zeros. And then hopefully, you start thinking greatest common factor. There isn't one, but you realize this is perfect cubes that we're looking at here, and this is the difference of two cubes. So that formula has that subtraction prominent in the first set of parentheses, and all addition throughout the rest. Our a value is 3x, and our b is 2. So this will be 3x minus 2, And then we have to be careful and do 3x, the quantity squared, and that is 9x squared. And then we have plus 6x, and then b is 2, so b squared would be 4. Now, first set of parentheses, 3x minus 2 equals 0. Our x is going to be 2/3. Second step, we have to find the zeros for this quadratic. Again, we're looking at something that's not going to be factorable, so we have to decide if we're going to complete the square or if we're going to use the quadratic formula. And I'm going to complete the square. So I have 9x squared plus 6x. Moving the 4 over, I have negative 4. Then I have to divide everything by 9, because when you complete the square, the number in front of the x squared term has to be a 1. So this will be x squared plus 6 over 9 will give you 2/3 x equals negative 4/9. Then we go ahead and go through the process of b over 2, so 2/3 divided by 2 squared. But again, with fractions, we don't divide. We multiply by the reciprocal, so that will be 2/3 times 1/2 squared. 2's are going to cancel out very nicely, and we get 1/3 squared, which is 1/9, which is great, because that then gives us a common denominator on the right-hand side. What we add to one side, we have to add to the other, and then we're going to write that perfect square trinomial as a binomial squared. And what we squared to get that 1/9 was 1/3. And over here we have a negative 3/9. Now normally we would want to reduce that, but we're going to take the square root in a second. So I don't want to reduce that because my denominator is going to work out very nice there. So square root of both sides, x plus 1/3 equals plus or minus, and then we'll have I square roots of 3 over 3, and in the end we can put that I in the back. So now we'll subtract the 1/3 from both sides. And like I said, let's go ahead and move that I into the back so that it is a complex number in standard form. So negative 1/3 plus or minus the square root of 3 over 3i. Next problem I wanted to look at here was number 9. Use the remainder theorem and synthetic division to find p of 4. So I don't know if you need this one, but I just love synthetic division and substitution. So that's the reason I'm going to do this one. We've got a 2x to the 4th, and then we don't have an x to the 3rd, so that's going to be 0. A negative 3x squared, a 4x, and a negative 1. And again, if you don't put that 0 in for the x to the 3rd term, you're going to wish you did, because you'll have to redo it. It does not work without that placeholder. And it said put 4 in. This was not a matter of an x minus a situation. They're telling us put 4 in, and what you get for the remainder is actually your answer. So bring down that leading coefficient, and then remember, outside the boxes multiply and inside the boxes add. And you oscillate from outside to inside, outside to inside. So 2 times 4 is 8. Inside the box we add and get 8. 8 times 4 is 32. Inside the box we add and we get 29. Outside the box we're going to need 29 times 4, so I'll just do a little good old-fashioned math over here. And we get 116. 116 plus 4 is 120. And then 4 times 120 will be 480, and 480 and a negative 1, adding those two together, will be 479. So 479 would be the answer. Again, by the remainder theorem, it's just that last number that we care about. That is our answer. Then, this one says you have several boxes with the same dimensions in number 10. And they have a combined volume of 2x to the 4th plus 4x to the 3rd minus 18x squared minus 4x plus 16. Determine whether each binomial below could represent the number of boxes you have. Well, in order for that to happen, it has to be a factor. So I'm looking at 10 and realizing, hey, I can do that one synthetically with that x minus a. I'm just going to put a 1 into this. And if I don't have a remainder, then I'll know, yes, this could represent the number of boxes. So I have a 2x to the 4th, 4x to the 3rd, minus 18x squared, negative 4x, and then a 16. So no holes in this one, everything is there. We bring down the 2, we multiply outside the box, add inside the box. 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 And our answer for number 10 would be yes. It works. We have a remainder of 0. Now, number 12, unfortunately, I cannot use synthetic for, and that's because it's not in that x minus a format. So I have my little 2x plus 8, and I'm going to have to divide by long division. 2x to the 4th plus 4x to the 3rd minus 18x squared minus 4x plus 16. I'm looking for the same thing. I'm hoping for a remainder of 0. So I have 2x plus 8, and I'm just matching that front term, so I'm going to need an x cubed. That will give me 2x to the 4th plus 8x cubed. Now, we change the signs, and we add, and it did its job. The first term is gone, so we're going to put that in the place of honor up there. 2x to the 4th minus 2x 4th, taken care of. 4x to the 3rd minus 8x to the 3rd will be a negative 4x to the 3rd. Bring down the next term. Now we have our 2x plus 8. And we need that first term to be a negative 4x to the 3rd, so that we'll use a negative 2x squared for. So negative 2x squared times 2x is a negative 4x to the 3rd. And then negative 2x squared plus 8 is negative 16x squared. Change the signs and add. Now it is definitely going to work, so I'm going to put that negative 2x squared up here, and I have negative 18x squared plus 16x squared, which is negative 2x squared. Bring down the next term. Go back to 2x plus 8. I need a negative 2x squared, so I need to multiply that by a negative x. That will give me a negative 2x squared minus 8x. Change the signs and add, and it did its job, so I'm going to put my little negative x up here. My x squareds are gone, and I get 4x, and I bring down my last term there, my constant. And I go back over here one more time with my 2x plus 8, and I see that if I multiply that by 2, I will get the 4x that I was hoping for. So I multiply by 2, and I get 4x plus 16. I change the signs, and I add, and the 2 works, so I put it up top, and I get a remainder of 0. So this again, the answer to this is yes. That could represent it. Can't do that one synthetically, because in order to use synthetic, we have to have a 1x. On the next page, it says, write each polynomial in standard form, then classify it by degree and the number of terms. So this is naming it. So first thing we're going to do is go ahead and FOIL this. X minus 1 times x plus 4, and just wait till the end to distribute the 3. So that will give us x squared plus 4x minus 1x, which is plus 3x. And then last times last minus 4. And then we go ahead and distribute. And we take a look and we see that this is a degree 2 polynomial. That means this is a quadratic. And we see that it has 3 terms, and that makes it a trinomial. Number 15 says, describe the shape of the graph of each cubic function by determining the end behavior and the number of turning points. And 15 is y equals negative 5x to the 3rd. So this is a cubic, but because it has a negative leading coefficient, it's going to look like that. So end behavior, limit, as x approaches infinity, our graph f of x is going where? Well, as you go to the right forever, you see that this is going down, so that will be negative infinity. And then the limit, pardon me, as x approaches negative infinity, for our graph, as we go to the left on our graph, we are going up. So that is positive infinity. And to determine the number of turning points, you would just grab your graphing calculator. But again, there are no other terms behind this negative 5x to the 3rd. So it is going to be a pretty standard backwards S curve here. So it has 0 turning points. The possibilities were that n minus 1. So 3, the power minus 1, which would give us either 2 or 0. And in this case, with no terms behind it, It's just going to be a really nice S-curve as you go through there. Then, number 17, we got a mega word problem here. It says you buy equal numbers of containers of strawberries, blueberries, and cherries. Cherries are $1 more per container than blueberries, and those are $1 more per container than strawberries. So the first thing I notice here is I know nothing about the cost of the strawberries. Now I work backwards, and it says blueberries are $1 more per container, so that'll be X plus 1 than the strawberries were, and cherries are $1 more than that, so that will be X plus 2. And then it says the product of those three individual prices is 5 times the total cost of one container of each fruit. Well, that total cost for one container of each fruit is what we get when we add all of these up. 3x plus 3. All right, so A says write a polynomial function to model the cost of your purchase. Well, what we're going to want to do is just go ahead and do the multiplication, move it all over to one side and take a peek at it. So we're going to use FOIL on those two trinomials. Over here I could just go ahead and distribute at any time. And then we're going to distribute the other x. Now what we want to do is go ahead and move everything over to one side so we get a good look at it. So x cubed plus 3x squared. Our 2x we would subtract 15x from and get a negative 13x. And then we'd move that 15 over by subtracting it. And I'm just going to use C of x for cost of x right there. So there's a polynomial function that's going to model what we see here. And then it says graph to find the price of each container. And remember, what you're trying to find is really the zeros. So I'm going to let you go ahead and do that part yourself. And once you find that zero, that will be your strawberries, and then you'll just add 1, and that'll give you the cost of your blueberries, and add 2, and get the cost of your cherries. And then in C it says explain how you use the graph to find the prices. You find the x-intercepts, the zeros. That's what we're always looking for. So grab your graphing calculator and go after that one, because this one is not factorable by grouping. Then number 18 says a cylinder has a radius of 3x minus 2 and a height of 3 minus 2x. And A says use 3.14 as pi and graph the equation for the volume. So I just want to remind you that the volume of a cylinder is pi r squared h, and that formula can be found on page 985. If you ever forget that, then we've got our nice formula page back there. So we are supposed to use 3.14, and then we are supposed to figure out its volume by putting in the information that we know. So the radius is 3x minus 2 squared, and the height is 3 minus 2x. And at that point, you can just plug that into your calculator exactly as you see it written there and graph that. And then use your second trace button to find your relative maximum. And then C says, what kind of limitation on the radius would make your answer in part B the maximum possible volume? So what you want to do is think about the fact that you cannot have a negative radius. So in this case, we'd have to say, you know what, we need this to be a positive 0 as we go through it, because we might see some negative zeros as well. But it has to be a positive 0 for that piece. Number 19, write a polynomial function in factored form with at least 3 zeros that are negative, one of which has a multiplicity of 2. So we need 3 different negatives, which would mean in that format x minus a, these are going to be positive. I'm just going to use x plus 1. That's a nice little easy one right there. And x plus 2, x plus 3, those seem easy enough here. Call that f of x. And then the last thing to do would be to make sure that one of them has a multiplicity of 2. So I'm going to give this little x plus 1 a power of 2 right there. We don't have to multiply this out or anything. It said write a polynomial function in factored form. So there it is.